Hey everybody, it's Mr. Chase again. I'm working on the compound events homework, starting with the using your math, okay? I hope things are going well and that you're able to follow through. Again, at any time, pause the video, all right? We're really just trying to check to see if you got the same answers as I did, okay? Let's get through these. A person is moving through a fun house at a carnival. First, they must pass through one of two doors marked A and B, and then they must choose one of the doors marked 1, 2, and 3. Create an organized list of all the possible paths the person could take. Okay, so what they're saying is, right, what could a person do? A person go through A and then 1, and A and then 2, and A and then 3. Or, right, they could go through B and then 1, B and then 2, B and then 3. Let's make that one look a little bit, oh no, that looks fine, okay? All right. Now, how many total paths are there? So I'm just counting up those options. 1, 2, 3, 4, 5, 6. There are 6 options. 6 different paths they could take. What is the probability a person chooses to pass through door B and then door 3? Okay, well, how many are B, then 3? There's 1 out of 6, right? Which we know is 0.16 repeating, or 17%. It doesn't say to do those other two, but 1 out of 6 is 0.16 repeating, or 17%. What is the probability that a person chooses to pass through door A and then an odd number? Okay, so let me think about it. Door A and then an odd number. Door A, an odd, that's this one. Door A and odd, no, that's even. So door A and odd. So now there's 2 out of 6, right? Which we can simplify to 1/3, or 0.33 repeating, or 33%. Okay, let me adjust that so you can see my answers down there. All right, so door A and then an odd was A1 and A3, 2 out of the 6 options. All right, letter D. Oh, and now we're on to question 2. If 2 fair coins, meaning normal coins, are thrown, what is the probability that they both land on the same side, both heads or both tails? Justify your response. Well, let's think about coin 1. Coin 1 could land on heads or tails, and coin 2 could land on heads or tails. So let's think about it, right? You could do heads, then heads, heads, then tails, or you could do tails, then heads, or tails, then tails. So there's actually 4 different options, but which ones of those are going to be both heads or both tails? That's 2 out of the 4 options, or 1/2 of the time you're going to be doing either a double heads or a double tails. Okay, and justifying my answer, that's me doing this work here and this work here. That's the justifying. Okay, number 3, top of the next page. 2 game spinners are shown below. The first is marked off in 3 equal sections and labeled with the numbers 5, 6, and 7. The second is also marked off with 3 equal sections, but marked with the letters E, A, T. Both needles are spun once, and the number and letter are recorded. Okay, create an organized list to create all the possible outcomes in the sample space. Okay, so I'm going to try to keep this neat as organized. You could do a 5, and then an E. I'll put a slash. You could do a 5, then an A, slash, a 5, and then a T. Okay? So that's all the options. Now I've used everything with 5. Let me just X out 5. Okay, what else could I get? All right, I could do a 6, and an E, a 6, and an A, a 6, and a T. Everything dealing with 6. Done. 7. 7 and an E. 7 and an A. 7 and a T. Okay. Sorry about that. 7 and a T. And a T. There we go. Okay. I used all the options. We're good so far, actually. Let's see how many are there. 1, 2, 3, 4, 5, 6, 7. Okay, there's 9 of them. So letter B. How many equally likely outcomes are there in the sample space? I just answered that. Oops. There's 9 of them. Okay. What is the probability that the needle will land on an odd number and a vowel? So it has to be an odd number. So can't use 6 in this case. It has to be odd and odd 5 or 7 and has to be a vowel. So 1 and 2, 3, 4. 4 out of the 9, right? Or 0.44 repeating, or we'll call that 44% of the time. You'll have an odd number, then a vowel. Okay, I like that one. Letter D. What is the probability that the needles will land on an even and a consonant? Okay, so even, so it has to be one of these 3 in red, but can't be because it's a vowel, can't be because it's a vowel, it has to be a consonant, right? Anything but A, E, I, O, and U. So 1 out of the 9, which is 11%, or 0.11 repeating. Letter E. What is the probability that it will land on a multiple of 3 and a vowel? Okay, so multiples of 3. Things that 3 go into evenly. No, can't be 5 and can't be 7. It can be 6, and it has to be a vowel. So let me think. 6E and 6A. So 2 out of the 9, or 0.22 repeating, which is 22%. Okay. Letter F. What is the probability that it will land on a number and then a letter? All of them, 100%, right? Or 1, the probability is 1, means it has to land on a number and then land on a letter. What is the probability that it'll land on a multiple of 4 and a vowel? 4, multiple of 4, multiple of 4. Nope, there aren't any of that. So that is 0 or 0%, right? Impossible. And what was the word for this one? Does anyone remember, right? When it has to happen was certain. Okay, looks like that's it for today. All right, I hope it went well, guys. I actually am enjoying this whole compound event probability thing, all right? It's pretty fun math. It's just a lot of counting, and sometimes you have to figure out all the options like we did above here. Try to keep them organized, right? That'll help you do the probability questions that you find below. All right, have a great day, everyone. Hope things are well.